Today I'm going to introduce you to the skeletal system. I'm going to start with the big picture and talk about skeletons generally, and then I want to talk about the functions, the types of bone cells, our histology, parts of a long bone, and then how bones develop. All right, in a big picture, in terms of critters on Earth, most critters don't have a skeleton at all. Look at this Spanish dancer. This is a nudibranch, one of my favorite non-penguin animals. Many other animals have an exoskeleton. Exo means outside. This is great for protection. Animals with an exoskeleton can often be hard and crunchy on the outside, but soft, juicy, and tasty on the inside. And then, of course, animals like us that have an endoskeleton. Endo means inside. Not much for protection, but really great for some other functions. Functions of the skeletal system, some are obvious, right? Protection and support, like your skull that protects your brain. Body movement, so muscles attach to the skeleton, not directly, but via tendons. And when muscles contract, they can pull across joints and we move. Hematopoiesis, literally this means the formation of blood cells. So all of our blood cells are made by the skeletal system, specifically tissue in the red bone marrow. And the skeleton also serves as a storage reservoir for fat in what we call the yellow marrow, as well as salts, including calcium. Types of bone cells. We have several types of bone cells. Mature bone cells are called osteocytes, which literally means bone cell. Osteoblasts. Believe it or not, blast means to build or to germinate. Osteogenic cells are the stem cells, where all bone cells come from. And osteoclasts break down bone. This happens during development as well as after a fracture. Now, the functional unit of bone is called an osteon. It includes a canal in the center, which goes by three different names: a central canal, the osteonic canal, or the Haversian canal. And in those canals, you'll find nerve, lymphatic, and vascular tissue. And then you see the osteocytes, those mature bone cells, which connect to one another via little canals called canaliculi, singular canaliculus. So because of the way bone is formed, which we'll get to later, osteocytes live in a matrix with organic and inorganic materials, but you'll see them sitting in what we call lacuna. The word lacuna actually comes from the Latin word for lake or pond or opening. So to remember this, remember the osteocyte, which as an adult will be trapped in its lacuna or lake, and it'll reach out to other cells through canals, little canals we call canaliculi. So when you look at bone histology, this is what you see. Now remember, bone is a type of connective tissue because the cells are widely spaced with a matrix in between. This matrix is comprised of organic materials, mainly collagen, and that helps the bone to stay flexible, and inorganic materials, mainly calcium salts, and that gives the bone resistance to compression. So here again, you see the osteon, the unit of the bone. You have the central canal or the osteonic canal. And here you can see the vascular, lymphatic, and nervous tissue that runs through it, servicing the cells. Let's pull out of the microscopic view and look at the parts of a long bone. Long bones have a shaft called a diaphysis. Dia just means through, think diameter. Two epiphyses, which we name proximal or distal. Remember, proximal closer to the trunk, distal farther away. Epi means on top. Metaphysis refers to the neck of a long bone. Let's take a close-up of the proximal epiphysis. So all of our articulating surfaces will be covered with articular cartilage. That's part of the protection we have for joints. You can see the spongy bone with the red marrow inside, and you can see the epiphyseal line, and I will talk about that when we talk about bone development. You can also see the medullary cavity, which is filled with primarily yellow marrow. Now, your specimens, of course, are not alive, so it literally looks like empty cavities here, but of course, in life, they are filled with living tissue. Moving down inferiorly, here we see the distal end of the bone. Now, the periosteum and the endosteum can be a little confusing, but they're shown better here. Peri means around, endo means inside. And again, you're not going to see this in non-living specimens, but the periosteum is where the osteoblasts or the bone-building cells live, and the endosteum is where the osteoclasts can be found. And again, osteoclasts are bone remodeling cells. And here you can see the blood supply. Bone is not particularly well vascularized compared to other tissues. But of course, the bone cells need a blood supply, just like any other living tissue. By the way, that word foramen is one you're going to start to see a lot when you start learning bone. It means a hole or an opening. The plural is foramina. Finally, bone development. Bone forms in two different ways. Intramembranous bone formation is when we have bone that forms from layers of connective tissue. Osteoblasts come in directly and start to lay down the bone matrix. Once they're trapped in their little lacunae, they become mature osteocytes. We see this type of bone formation mainly in bones of what we call the cranial vault in the skull, as well as some facial bones. The rest of the skeleton forms via endochondral bone formation. Literally, it means inside cartilage. And basically, it's bone that forms from a cartilaginous framework. So chondrocytes, these are cartilage cells, they build the framework first. And then osteoblasts come in and replace the chondrocytes. And this happens in two different areas of long bones called ossification centers. Because of the way the bone forms, there's going to be a line where the primary and secondary ossification centers meet. And when you look at an X-ray, you can see if a bone has finished growing. So here we have the cartilaginous model, and you can see the primary ossification center is in the diaphysis. That's where the ossification starts. Secondary ossification centers occur in the epiphyses, in the ends of the bone. And between the primary and secondary ossification centers, you see the epiphyseal plate. When that epiphyseal plate is completely ossified, when it's all bone and no cartilage, the bone has completed growing. So that's how you can look at an X-ray of a child and determine whether or not the bone has reached its maximum length. As always, I hope that was helpful. Thanks so much for visiting the Penguin Prof channel. Please slam some buttons below, and I'll see you in the next one. Good luck.